Previously, we said that the study of chemistry is absolutely essential for the full understanding of biology. Today, we want to combine atoms into molecules. While atoms are the fundamental pieces of elements, the makeup of our bodies, proteins, nucleic acids, and more, are molecules, assemblages of atoms. So, our questions today are, why do atoms combine to form molecules? What is a covalent bond? What are molecules? And what are the properties of molecules that determine their function? I'm assuming that you understand the general structure of an atom, protons, neutrons, and those wonderful electrons whizzing around the nucleus at the speed of light. Those electrons will be our focus today. This is a common representation of atoms, with electrons placed in concentric circles, which represent shells. You might want to think of the atom as a building, with floors of the buildings being shells. Hydrogen is a building with one floor, carbon has 2 floors, and sodium has 3 floors. The top floor, or outermost shell of any atom, is referred to as its valence shell. In each floor, there are rooms, or orbitals, the physical spaces, which electrons exist. Notice that the electrons are either paired or unpaired, and that the unpaired electrons are always in the valence shell. So why do atoms combine with other atoms to form molecules? Returning to our building analogy, the electrons want roommates, and they can turn to other atoms for them. Said more accurately, atoms possessing unpaired electrons are highly reactive, and they can fill their vacancies in their orbitals by sharing electrons with another atom. We see this with molecular hydrogen and methane. Note that the junctions between the 2 hydrogens of molecular hydrogen and that between the carbon and the hydrogens of methane possess a pair of electrons, 1 electron from each atom. This is the covalent bond, a shared pair of valence electrons between 2 atoms. Covalent really means sharing, co, of valence, valent electrons. This bond is very strong and absolutely vital. Without covalent bonds, we would not have molecules. With the electrons paired in orbitals, the H2 and methane are much less reactive than the individual hydrogen and carbon atoms. They're certainly not unreactive, but they're less reactive, more stable than the individual atoms. So what we have created here are molecules. A given molecule has the same atoms, the same number of each atom, and even the same connections between the atoms. Methane always has 1 carbon connected to 4 hydrogens. Ethane always has 2 carbons. Each is attached to the other carbon and 3 hydrogens. Remove a couple of hydrogens from ethane and it's no longer ethane. It's something called ethene. And even though these molecules are very similar, they have slightly different properties. We could say that they have different functions. So why is that? What are the properties of molecules that determine how they function? It really comes down to 2 things. 1, what's the charge? We'll discuss that later. And what is their 3-dimensional shape or structure? Let's think of the structure-function relationship. This is something you're all very familiar with. You know that a glove only functions because a glove is shaped like a hand. Its structure determines its function. It protects your hand, it keeps it warm, while allowing you to pick up items, zip your coat, and do other things that your hand is supposed to do. If your glove were shaped like a hat or a shoe, it wouldn't work well. It would have a different function. And what determines the structure of the molecule, we'll see as we continue our lectures, is the bonds that the atoms make. And those bonds are in large part determined by the environment surrounding the molecule. Well, I hope you found this helpful, and I'll see you in the next video. Thank you very much for watching.